Hi, welcome to VMware vDefend Security for VCF 5.2. This is the module on malware protection. My name is Jeff Shukin, and I'm one of the security product managers here at VMware by Broadcom. In today's typical advanced persistent threat scenario, we see attackers leveraging multiple different stages of attack to get to their ultimate goal. From initial access, which may include things like app vulnerabilities, malicious files, phishing, stolen credentials, all the way through to lateral movement through the infrastructure, getting to their ultimate goal of the interesting and valuable data within the organization. Now, it's these attacks that are difficult to put together and see from a holistic perspective, and each stage of the attack requires a slightly different security control. For the initial access, sandboxing can be a fantastic way of watching for both known and unknown malicious content. So malicious content that is being downloaded, say, with the click of a mouse button and a web page that a user is on. Or it could be tracking the lateral movement using our own tools and techniques against us. Things like the RDP protocol or pass the hash type of attacks against Active Directory and Kubros. Finally, it could be good old exfiltration out known channels in the organization using DNS tunneling, things of this nature. It's important to have a security control that can identify and prevent attacks at each of these stages. It's also equally important, as you will hear in a subsequent module, to be able to put all of these atomic events together and understand the overall attack as it's occurring. I'm sure you've seen this slide a few times by now, but it's important to remember that the security features in NSX are built upon what I think of as the foundational layer of distributed firewall and gateway firewall. You need to have some sort of security enforcement point to be able to layer on these types of preventions. You also need a top level of security analytics and management to be able to put these things together. But today, in this module, we're specifically going to focus in on malware prevention and malware detection. And we're going to talk about where you can do detection and where you can subsequently do prevention. Now, what are some of the benefits of the way we typically look at malware detection and prevention capabilities? The first one is you need to have both static and dynamic malware analysis. What do I mean by this? There will be a great number of files that we can very, very quickly discern that are malicious. We can do this through, some very normal and well understood pattern matching type of methodologies, either YARA rules or simply looking at the hash. And we can very, very quickly prosecute these files and know that they're either malicious or not malicious. And we need to be able to do this in a very, very quick and efficient fashion. Approximately 1 in 100,000 files are probably going to trigger something in this initial access. And it's important to be able to take that to the next stage, which is the dynamic analysis. So this could include things like code analysis, all the way to running and detonating a file in a controlled environment sandbox. So this needs to be able to handle files in a very quick and efficient fashion, and needs to be able to tell known good and known bad very quickly, and focus the more time-intensive techniques for the second or the far fewer number of files. Now, encryption continues to be an issue within security, and most vendors tackle this by doing some sort of TLS inspection, either at a gateway or some inflection point within the network. We all know that this is extremely expensive in terms of processing. Typically you'll see devices rated for 1 gigabit of throughput, but when they're doing TLS inspection, the performance will fall 10 times or even more. The way that we do this is actually kind of interesting in that we don't focus on having to decrypt outside of normal channels. we utilize something called the guest introspection agent, which we'll talk about here more in a minute. But the guest introspection agent runs on the virtual machine and is basically able to trap files that are being written to the disk and intercept those files and send them to the malware prevention engine. Now this is very interesting because the price or the cost to decrypt this or unobfuscate this has already been paid. If this is coming over an HTTPS connection, you would have to have this normally decrypted so that file could be written to disk. Our ability to intercept that as it's being written to disk is very unique and is very low cost in terms of additive processing power that may need to be done in the environment. From a file size perspective, we actually support up to 104 file types with the 4.2 release, and we can examine files that are up to 64 megabytes in size. So, large files, that's something that you'll have to deal with in another matter. But typical files coming down to a desktop or a server being uploaded, as long as they're 64 meg and lower, we can deal with that. As I mentioned, there's over 100 file types. You can consult the documentation for all 104 of these. And last but not the least, operating systems. We support all Windows operating systems that are reasonably new, so I think from 2012 and beyond. We also support a variety of Linux operating systems from Red Hat, SUSE, Ubuntu, and CentOS. So no matter what you're running in the data center from an operating system perspective, you can support the guest introspection agent on these platforms. Now, as I mentioned, we're using the guest introspection, the GI architecture, to intercept these files. And if you have been around VMware for a while, you'll realize that this is a technology that's been in use for quite some time. The GI architecture was actually used in agentless antivirus years and years ago. So rather than having an antivirus engine running on each virtual machine and having what we always affectionately called AV storms, we were able to look at files being written to disk, send those to the antivirus engine, and save the intensive scans for times of maybe less load. So the guest introspection agent runs as part of VM tools. It's a very thin agent and basically is able to trap, as I mentioned, file writes, send those through the MUX on the ESXi hypervisor to a security virtual machine, an SVM. That SVM runs as part of each ESXi host. And on this security virtual machine, you have something called the security hub, the event collector, and RAPID, which is an acronym that stands for our ability to look at files in a quick and efficient fashion. This SVM is a black box for all intents and purposes. You don't have to worry about it, manage it, update it. It's taken care of for you as part of the EAM process. But it's responsible for quickly prosecuting files, determining whether they warrant additional inspection or not. Now, if you so choose, and this is an opt-in process, if you have a file that is, we're not sure, this could be indicative of malware, we're not 100% sure, it would benefit from actually running this in the cloud-based sandbox, you can, by policy, send that file from the security virtual machine through the NAP or SSP platform, depending upon the version that you're running, both are supported, to the VMware Threat Intel Cloud. Now, this is a hosted service that you would consume. You don't need to set anything up, and we're able to detonate and prosecute files in a dynamic fashion in the cloud. So in this case, we're sending files to be executed like they would be in any environment. There's a network, there's a user interacting, there's everything that we need for the malware to sort of do its thing, and we simply watch what happens on that sandboxed machine. We look for signs of known malicious activity, and if it adds up to being a malicious file, we can quickly signal back to you that, hey, yes, a malicious file has been downloaded in your environment, and you do need to treat it as such. So next, let's look at where we can actually do malware detection and malware prevention. And it comes down to two separate enforcement points. We can do malware prevention at the guest OS level. So these virtual machines running Windows or Linux, you see here in blue on the overlay, as well as the VLAN backed segments on the right. these virtual machines can be equipped with the guest introspection agent, and by policy you can say, hey, if a user downloads a piece of malicious content, that it can be blocked from ever being written to the disk. Now we can do malware detection at a different level. We can actually do that at the gateway level. So the gateway firewall, or part of the edge services node, we can actually take a look at files being transported or basically moved either on the uplinks or service interfaces, and we can have that for perhaps those virtual machines or physical hosts, bare metal hosts, that can't have the agent or won't ever have the agent installed on it. This can be a really nice way of looking at files where maybe I have something that is a little bit older, or I don't have the ability to install VM tools. I can do malware detection at that level. As I mentioned, distributed, the virtual machine level, I can do both detection and prevention, and this works again on Linux as well as Windows virtual machines. So you have a couple of different interesting places to run malware detection, malware prevention in the environment to suit your requirements. So just kind of recapping really quickly, distributed malware detection and prevention, that would be running at the guest OS level, offers detection and prevention by policy. It works on Windows and Linux, and of course requires the guest introspection, the file introspection driver on the virtual machine. This is part of VM tools. And it's, from all intents and purposes, protocol agnostic. It doesn't really matter how that file was moved through your organization. If it was done over HTTP, HTTPS, even if it was someone who's using the iDRAC or remote management capabilities of a server to mount a CD-ROM or a USB key, and it's being moved in that way, as soon as that file is being written to disk, and of course it has to be written to disk in its native format, free of any encryption or obfuscation, we can actually intercept that file. And it's important to note in the latest release, these events are sent to NDR. So if there is an NDR service running in the environment, the malware detection and prevention will feed rich telemetry into that environment so that you can correlate all the different atomic events of a particular attacker's campaign and see what the attacker is actually doing. From a gateway perspective, as I mentioned, we're now targeting any VM that maybe we can't run a guest introspection driver, physical servers, and so on. This is detection only. We don't have ability to, at this point, be able to prevent that file from being sent through. And it only works for a few files types, HTTP and FTP. And optionally, if you have the TLS inspection capability configured in the or on the gateway itself, we can do files that are being transported over HTTPS. And like distributed, the gateway can send these events to an NDR in the environment. So if you do have that set up, both gateway and distributed will send those events to NDR. And by the way, that's a 4.2 release specific. That might not be true for 4.1. Now let's take a look at actually how this is going to work. Let's actually see a file being downloaded as it goes through different places here in the environment, and we'll kind of get a sense of how this actually works. So in this case, I have my gateway running malware detection, or I have my virtual machine configured with the guest introspection agent running malware prevention. And let's actually work through a file being downloaded here. So I'll go ahead and click the mouse and build the next file, or build the next build. And so at this point, we have a file being downloaded, and we're quickly taking a look at the file hash. Now, as you probably know, a file hash will be unique for any file. Any small change to a file will change the hash. But this is a really good way of separating known from unknown, or good from bad, and doing it very quickly. And so the result from this will either be benign, and that'll be, in essence, we're saying, hey, we know this to be good based upon all the other instances of this file being, examined in environments, or it's potentially malicious or suspicious. We could come up with a suspicious verdict as well, in that we don't We've not seen this. It's not showing any signs of malware, but when we look at things, this doesn't look terribly normal. Again, it's really important to be able to do this very, very quickly and efficiently to separate, the majority of files which will be known to be good from potential malicious or suspicious files that we do need to take further look at. So if this file, or if this, this executable comes through and we've never seen it before, this will will require some additional processing here. So now as we get into the dynamic type of analysis, and again, this is being done locally. This is staying on that security SVM that we talked about a few slides ago. And we're going to do things like, any dynamic sort of analysis that we can do. So we can actually take a look at, the file format, look at the code. If it's a Python file, for example, we can run some, sanity checks against that. And it's going to come up with, 3 different results or verdicts here. It could be benign, and okay, we've looked at it. Yeah, this is just a normal file. A good example might be a Word doc. Yeah, it's a Word doc. We've never seen it before because Word docs are typically unique, but there's nothing in the Word document that actually looks malicious. There's no Visual Basic code or anything like that that's going to cause us problems if that user opens the file on their desktop, so on and so forth. Could also come back as malicious or suspicious. So this is, we've looked at it and say, oh yeah, there's definitely signs of malicious content in here, and we want to mark it as such. Or it could come back as, in progress. And this is the, hey, we're not sure, we'd really like to send this file to the sandbox for further analysis. Now, you absolutely can stop at this level. There is no requirement for you to send files to the cloud. And in fact, there will be certain organizations and certain file types that you probably won't want to share the file with the cloud. A good example might be, those Word documents or PDFs. They could contain sensitive information. You wouldn't want those being uploaded into the cloud. And by policy, you actually have the power to say, I'd like these files to be looked at and those files not to be sent to the cloud. You have this policy granularity to say what you want to have happen. So let's say that you do have a policy that says, yes, I do want to send in-progress files or these files that we're not quite sure about. We'd like you to send those to the cloud on our behalf. We can optionally go ahead and send those. So this file will now be sent from the security virtual machine through Security Hub into the cloud for more analysis. So this happens in the cloud on your behalf. There's nothing for you to set up or worry about in terms of upkeep or bills from a cloud service provider. And so this file will be sent to the cloud-based sandbox. It will literally be detonated or executed or opened or whatever the case may be, and we will watch for the behavior. So again, this behavior could come back as benign. Yeah, false alarm. Nothing in the file actually showed us to be malicious. Excuse me. Or it could come back as, yes, absolutely, this is a malicious file that is doing things that are very indicative of malware, and we can quickly signal back through the channel that you've potentially downloaded a malicious file into the network, and that you need to go ahead and launch a cleanup process. So this is kind of the way the detection and prevention services can work. Again, you can do this on the gateway or the end virtual machines if you so choose, and have that complete protection. So let's contrast a couple of the different techniques that we talked about here. So we talked about local versus cloud. Well, what is local really good at? And so we do have a really fantastic mechanism for basically pre-filtering both known good and known bad files. And we can do that by looking at things like the file signature, that's a hash, file structure, URLs, any JavaScript, Visual Basic for applications, XL4 code, key strings, Yara rules, anything that we can use to quickly signal that yes, we've encountered this before and it's either good or bad. And basically this is going to process the lion's share, the majority of the files in the environment. And it's going to do this very, very quickly, and from a delay or the the file being held and being written before it gets written to disk, it's really negligible to the end user. We can do this very, very quickly, and because we're doing it within the same ESXi host, the latency is negligible. Of course, we can determine in this case if cloud analysis is needed, and you determine whether by policy you wish to go ahead and do this. And so again, we do have this. It was actually came from Last Line, the acquisition we did several years ago, and it's a cloud-based sandbox. And we're actually going to now execute that file in a controlled environment and watch what it does. For example, does it change the desktop message, on the workstation that we're executing on? Does it change the background? That's a telltale sign of a ransomware attack that, they're going to give you the instructions on how to actually pay the ransom, through the Bitcoin address right on the desktop. So this again is very, very quick, but it is something that we feel should be run in a controlled environment outside of your network. So just kind of bringing this back from a gateway perspective, we talked about this. This is detection only, so we can detect known and unknown files. We support this on the T1, so this is the uplink and service interfaces. We can do all of the different file types here, and again, we need to either have it in clear text or have TLS inspection enabled to do any encrypted content. We actually end up using the IDPS file-based extraction mechanism. So this works kind of hand in hand with IDS, and it's actually a really, really clever way of grabbing files. Again, without any re-architecture of the network. We're not hairpinning traffic, forcing traffic to go through artificially created inspection points. It's just as traffic flows in your environment. Of course, the distributed is capable of detection and prevention, as we've kind of mentioned. Supports Windows and Linux virtual machines. All the file types are supported, as we've talked about, and can be a really fantastic way of an additive security control that maybe sits alongside of things like your EDR, as an example. So if you have Windows Defender running, it's going to look for those things that are being done after the file is being uploaded, but this deals with anything up to it, including that initial access that we talked about in the first slide. So with that, I want to thank you for the time, and please enjoy the rest of the content, and we'll see you next time.